So we have Unit 4, Lesson 8, Rational Equations, Part 2. Again, this is our last rational expressions, okay, or equations lesson before we go to absolute value. Yes? No. I don't believe we are. I will double check. Okay, so in this lesson we'll solve rational equations which reduce to quadratic equations. We'll also consider the equations to have no solution. So now we really have to use our verify, okay, because we're going to get those where we try to verify it doesn't work, so we have to say there is no answer or no solution, okay, or extraneous, right? Okay, if the equation consists of a single rational expression on each side, use cross multiplication. We talked about that earlier. If the rational equation has more than one term, more than one term on either side, consider multiplying the term by its lowest common. That's what we did in our warm-up here. The lowest common was n plus 1 in our example of today. And then use previously learned skills for solving equations. So just your basic solving strategies. Okay, and always be aware of your non-permissible values. All right, so let's get to our first example here. Okay, so in example 1, in the previous lesson, we solved the equation graphically with our calculator. The solution was we got 0 and 2. Whoa. Got my highlighter on. Let's get this back to the stick here. All right. So we had 0 and 2 with our solutions when we did that graphically. Okay, now it wants us to do it algebraically. Okay, so first thing we want to do is we're going to put our non-permissibles. It's always easiest to do that first. So we can't have a plus or minus what? 1. So plus or minus 1 is non-permissible because it gives us 0 on the bottom. Again, our non-permissibles come from 0 division, dividing by 0. Okay, so then what strategy would you want to do here to solve for this? Again, what's the problem? The problem is the fractions, and we want to get a common denominator. So this is how you want to do it. Okay, we're going to multiply. What I do is, let's do it this way. I'm going to explain it this way to you guys. Let's see if you guys like it. This and this are my problem, right? I'm going to take those two things as a product, x plus 1, x minus 1. I'm going to multiply that to every term I have. Okay? So I'm going to multiply to every term I have, so I have this. I'm going to here, I'm going to go x plus 1, x minus 1. To here, x plus 1, x minus 1. And then to the 2, x plus 1, x minus 1. I multiply to every term I have. And I do that because why? Why do I want to do that? Yeah, it's going to cancel the denominators in every situation. So now those are gone. Now I feel a little bit better. Hopefully you do. So now I have this. I have 3 times x minus 1 plus 1 times x plus 1 equals 2 times x plus 1, x minus 1. So now everything's on one level, and now we're just using our basic algebra solving skills. Okay, so if I distribute here, I get 3x minus 3. Don't really distribute a 1, so it's going to be plus x plus 1. My right side, I know it's a difference of squares, so it's going to give me 2x squared minus 2 when I distribute. Okay, and now we want to try to move everything to one side. So I have 3x and 1x is 4x minus 2 equals 2x squared minus 2. I'll move this up this way to keep my x squared positive. The negative 2 plus 2 cancel. So all I'm left with is 0 equals 2x squared minus 4x. What do we want to do now? We don't have an answer. What do we want to do at this point? Does anybody think, do you see something you may want to try? You may not feel like that's the right thing to do, but what would you want to try? What's that? Yeah, take out 2x. If I take out 2x, I get x minus 2. Now we're like, oh, I can solve by factoring. What does this yield me? An answer of? And what's this yield me? Answer of 2. So I get 0 and 2 as my answer. And so we just solved it algebraically. Okay, any questions or concerns on that? And we won't verify this one because we did this on our calculator. We're fine with this one. The next couple we will. Yes, sir.
If it was just 2x before x, you just put it in
Yep. Okay. Any other questions at all? Okay. All right. So here we go. Moving on. All right. So example 2. Solve the rational equation by cross multiplication. So, like, what's it mean by cross multiplication? Like, how are we going to do that with cross multiplication? Yeah, 2 over 1. So really all it's telling me is to multiply x plus 1 over, because the 1 doesn't do anything. Okay? So that's what it's asking me to do. Good. Thanks, Eli. And then what's my non-permissible? Negative 1. X can't be negative 1 for my non-permissible. Okay, so is everybody okay if I'm just going to, x plus 1 is going to multiply to here. That's what I'm going to do. Okay, so here we go. X squared minus 5x minus 6 equals 2 times x plus 1. X squared minus 5x minus 6 equals 2x plus 2. Minus them over. Okay, x squared minus 7x minus 8. I'll pause. I know that was very quick. Yep, no, I know. That's why. Give you guys time to write it. Gives me a water break chance, so my voice doesn't crack or anything. All right, and Lindsay, what is this factor to? What are factors for 8 that are 7 apart? Good, negative 8 and positive 1, right on the nose. Okay, and so then, Gabby, you know this, what makes these 0? I know you're doing something else. What makes these zeros?
Negative 8 and positive 1.
Other way. What? Opposites, right? Yeah. Yeah. It's 8 and negative 1.
Is that not what I said?
You said the opposite. You said negative 8 and 1.
Oh, well, that's what I meant.
I know. That's why I corrected you. No, you're good. You're good. Okay, so 8 and negative 1 are answers. So now we're good. We're going to check them though. Okay, so I'm going to try 8 first. So just stay with me here. Do a lot of it just verbally. 8 squared is 64. Minus 5 times 8 is minus 40. Minus 6 all over 8 plus 1 equals 2. Okay, 64 minus 40 is 20. Minus 6 is 18. 8 plus 1 is 9. Is 18 over 9 equal to? Yes, so that one's verified. So this one's, we're good with this one. Yep.
So you know when it's factor it like that, if when you move everything over and it equals 0, like how wouldn't that work? Like why? Like when we were doing an example like on the warm up, and we got like we did like 20 y divided by 20 and that's y equals 0. Like on another one we got like 1 like n equals 1.
Well, the ones that are warm-ups were the special situations because we didn't have any squareds. We had just the variable.
The reason why it works is because there's an x squared.
When there's an x squared, you're going to have to factor. When you're an x squared, you're going to have to factor a GCF because we need to get that not to be an x squared. And so in our examples in our warm-ups, like the first one, the x squared canceled, and then the second one, our x squared canceled, and our first one, we didn't have an x squared or an m squared. Yep. See over there, the 6y squared just went away because they end up being the same. About the.
Is that a 6y squared or 6y minus 2?
Nope, right here. 6y squared and 6y squared.
Okay.
Whenever you have a y squared, you're going to have to factor. Unless they cancel. Okay, so let's try negative 1 real quick. So negative 1 squared is 1. Negative 1 times 5 is positive 5. And then minus 6. Ooh, that's correct. Negative 1 plus 1, as Sarah just pointed out, okay, is 0 over 0, which is still not good. So we reject this one, and it's our non-permissible. So, Sarah, you're definitely ahead of the game. Good. I like it. So negative 1's rejected. So you just say not negative 1, your only answer is 8.
Wait, could you just, sorry, I'm probably off, but, since you know you're non-permissible with negative 1,
yeah, you can just say it can't be. I was just showing you that it's not because you get 0 over 0, which is a concept you're not ready for mathematically. Okay, all right, so part B, it says, explain why one of the solutions to the equation formed does not satisfy the original equation. Why was it? It's a non-permissible. That's what that basically wants you to say. It's a non-permissible. All right, only have 2 examples left, so shorter day. Okay. Uh-oh. Okay, state the non-permissible values. So, what is my non-permissible value here, Davin? There's only one. No. Because if it's negative 2, 2 divided by 2 is negative 1. That's okay. It's just an x on the bottom. So what can x not be? 0. Okay, so x can't be 0. There's no problem with this one. Okay, the 3 obviously doesn't have an x on it, so there's nothing there. So how do I want to, Logan, how would you approach part A there in terms of making it ready to solve, or what do you think you'd try to do? Right, multiply x to everything. So I get rid of this if I do that. So I multiply x here, here, and here. So then this cancels, so I'm happy because my fractions are done. And now I have x squared plus 2 equals 3x. Minus the 3x over because I have an x squared. I think I'm going to factor. Okay, can you factor that, Tom? Oh, it's all right. We're going to factor the 2 that I have 3. Yeah, negative 1, negative 2, yep. Okay, and then, so what are my solutions here? Spencer, what's my solutions then? Okay, good. Are these non-permissible? No, neither are non-permissible. Okay, so we're still going to verify though. So let's verify from the beginning. Let's do 1 first. So we're trying x equals 1. I get 1 plus 2 over 1 equals 3. 1 plus 2 equals 3. Verified. 1 plus 2 does equal 3. Let's verify 2. 2 plus 2 over 2 equals 3. 2 plus 1 equals 3. That's verified. Any questions so far? All right, so Quinn, what would you want to do on B? Like just to start it. We'll do the non-permissibles after you tell me what you would do first. Okay, yes. What's that? In terms of factoring it, or? Yeah, that might make things a little easier. Let's try that. So x, you have x plus 4, x minus 4. Okay, good. Ah, yeah, 2. You're right. Thank you. 2 minus 2 over plus 2. Okay. So now you're going to cross multiply. That's fine, but I think what might be easier, I'm trying to think about the best way. Like if we cross multiply, this would go here. We get x plus 2 times x equals 2 times x plus 2 times x minus 2. But what do you notice? We have 2 what? Yeah, these are pretty much, I could say, well, I'm going to divide this off or whatever, but these are going to cancel because they're both on the same side. Okay, before I do that, my non-permissibles are 2 and negative 2. Yeah, you could. I think actually what I would do, Kyle, personally, I would probably just multiply this guy over and then just cancel them and then put the x minus 2 over. That's what I would do. But, I mean, yeah, either way is fine. They will cancel. So x equals 2x minus 4. I just got that from 2 times x, 2 times negative 2. I'm going to minus an x. 0 equals x minus 4. Add the 4, or we know that x equals 4. Okay. Let's see here. Yeah. So I'll just stay with what I've done. It's fine. This is good. All right. So 4 is not non-permissible, so we can plug that in real quick. So that'll be a 4 over 16 minus 4, because 4 squared is 16. That gives me 12, which is 1/3. And 2 over 4 plus 2 is 2 over 6, which is 1/3. So they are equal, so x equals 4 is okay. Okay. Yeah. I want to just. All right, we got one more example. All right, last one. Okay, so show that the equation 8x plus 10 over x minus 3 minus 4 equals 10x plus 4 over x minus 3 has no solution. So that's kind of weird. They're telling us that it has no solution, so we're going to figure out why. Okay, so first thing, my non-permissible is going to be x can't be 3. Okay, we know that. Now, this is kind of a different one. It's actually like our warm-up. What do we want to do to get rid of the fractions? Yeah, times everything by x minus 3. So x minus 3, x minus 3 to the negative 4, and then x minus 3. We like that because it gives us a nice cancel here, nice cancel there. So we're going to have 8x plus 10 minus 4x plus 12, multiply the negative 4 in, equals 10x plus 4. Okay, so I'm going to combine all my like terms here on the left. 8 minus 4 is 4. 10 plus 12 is 22. Okay, minus 4x minus 4x. 22 equals 6x plus 4. Yep. Okay, minus 22 minus 22. 0 equals 6x minus 18. Now you can GCF or you can move the 18 and divide. It doesn't matter how you want to do that. I guess I probably should have minus the 4. Let's do it that way. Sorry. I'm into my GCF mode. Algebra-wise, it makes more sense to do this. 18 equals 6x. Divide by 6. Divide by 6. X is 3. Reject. So you just prove that there's no solution. The answer we got was 3, but it's not a possible answer. So you reject it. And you would just say no solution. So what that means, what's that mean? Let's see if we get this, smart kids. What does that mean graphically? Not that. In this case, not that. If it was equal to 0, you'd be right, remember? So if we have one side equal to 0, that means that we're looking for x-intercepts. But this is two things equal to each other, right? So remember our first example yesterday? What were we looking for? When we set two equations equal to each other, we were looking for them to cross, intersect. Remember the intersect feature? So if I put the left side in my calculator as y1, I put the right side of my calculator as y2, by us getting no solution, that means that those graphs will not cross. It means they will never cross each other. Okay? That's what it means, graphically. Okay? Any other questions? Okay, so